Next, formulation for a manufacturing problem. Now a small manufacturing firm produces two types of gadgets A and B, which are first processed in the foundry and then sent to the machine shop for finishing. The number of man hours of labor required in each shop for the production of each unit of A and of B, including man hours per week, are as below. For gadget A, foundry and machine shop 12 and 10, gadget B 8 and 6, and firm's capacity per week is 2000 and 10,000. The profit on the sale of A is rupees 50 per units and on the sale of B is rupees 30. Now determine the weekly production of the gadgets A and B so that the total profit is maximized. Formulate the linear programming problem. Now we are having, let the decision variables, let x and y be the number of gadgets A and B respectively. Let x and y be the number of the gadgets of A and B respectively. Now obviously what we are having now? X is greater than equal to 0 and y is greater than is equal to 0. Now mathematical formulation. Now first thing was the profit on the sale of A is rupees 50 per unit and on the sale of B is rupees 30 per unit. Now profit maximize Z is equal to rupees 50x plus 30y, and this is objective function. On profit, objective function on profit. Now subject to constants. Now we are having gadget A foundry for 12 and machine shop for 10, gadget B foundry for 8 and machine shop for 6. So we are having 12x plus 8y is less than is equal to 2000. Foundry constants. Then 10x plus 6y is less than is equal to 1000. Machine shop constants. Then we are having x is greater than is equal to 0, y is greater than is equal to 0. These are what called non-negative constants. So now we can solve the question.